to this cellular network providers, but no other do. You take Ola cars or they all rely on this technology only, because that is only good for long range continuous seamless tracking of vehicles or whatever it is. Okay, even for wearable device, this is the good choice. From your device to mobile phone to the data server. So cellular network is best choice for long range connectivity. So wherever you go, you can be easily track that. Okay, smart metering, all this will be a feasibility now. Okay, earlier, see, if I use a smart meter, electric meter in my home, then I should have connectivity to the Wi-Fi router. Then Wi-Fi, through Wi-Fi router, it goes to the cloud server. But imagine if the smart meter directly communicates to a cloud server through the cell phone network. So the user is totally disconnected. You just fix it, data will be automatically going to the cloud. You cannot do anything with that. Okay. So implementing long range tracking became a feasibility with this cellular network protocols. Okay. 5G definitely can provide more options for us, but 5G is not standardized actually. So I didn't put any specific frequency for 5G here, because I'll just give an outline. It is not at freezed. The standards are not at freezed actually. So they are using that in specific regions with their own standard. Okay, it's not globally freezed. Okay, cellular is good for the long range. Short range, you can use BLE or Wi-Fi Halo. And then the other one, somewhat, this is a medium range, I could say, not long range like cellular network, some medium range. You can use LoRa. Most of you could have heard this LoRa technology, long range WAN. It supports the same TCP/IP protocol, and of course, somewhat reduced version of the TCP/IP protocol. But with this, you can't have continuous tracking, seamless tracking. You should have gateways. Suppose if I in a area of 100 acres, 200 acres, I want to track, then this is fine. Otherwise, if I want to track a vehicle going on a highway from one state to another state, I cannot continuously track this. If you want to implement with LoRa WAN, then you should have a LoRa gateway every 15 kilometers actually. Then only continuous tracking with LoRa WAN would be feasible. Like cell phone towers, you should have a LoRa gateway every 15 kilometer radius. Then if any device uses LoRa protocol, that will get connected to the gateway and it will be updated in the cloud server and it will be able to take. But it's a private network. The advantage is that no subscription is required. Okay. So many people are in industries, they are adapting this LoRa WAN. Okay. As long as they are having their own gateway. Suppose if they know their vehicle passed through certain route, they will fix the gateways only in that particular route actually. So they will be able to do live tracking of the vehicles with LoRa WAN also without relying on the cellular network. So subscription cost can be greatly eliminated, and it is their own proprietary network. Proprietary network means no one else can have access to that data. Actually, they can only monitor. So LoRa WAN is next level protocol for long range tracking. But nowadays it is being promoted with installation of LoRa gateway. Actually, they are trying to provide or install LoRa gateways at so many places, and very soon long range connectivity with LoRa WAN protocol will be a reality. Okay, right. So other one is Sigfox. It's a sub 1 GHz. All these are sub 1 GHz. It means they require it's a lightweight data format they use, require less bandwidth. Sigfox is similar to LoRa WAN actually. For monitoring in a particular location, people will use Sigfox. Okay, these are the popular things. LoRa, Sigfox rarely, the LTE can use, and then Bluetooth low energy and Wi-Fi hollow. These are the popular connectivity solutions for IoT devices, be any application, healthcare or smart lighting, whatever it is. But these are the feasible communication protocols. Okay, so everything has its own merits and demerits. It's we have to make a decision on that, which one we are going to use. Okay. And wearable devices and 5G. Is there any upgradation that will come in the 5G? For 5G standards implemented, will it do anything good to the wearable device technologies? You know, 5G is a faster network, and it's about the latency actually. With 4G, you see the latency was around 10 to 100 millisecond, but with the 5G, the latency will be reduced to 1 millisecond. Okay, so one end-to-end communication can happen with a latency of less than 1 millisecond. It is possible with 5G actually. Okay, and the frequency band 5G, they are exploring the entire frequency spectrum. 5G doesn't mean it is using a higher frequency band. So they are trying to exploit even the one lower sub 1 gigahertz spectrum, sub 6 gigahertz, and millimeter wave. Okay, so high-end applications will explore and try to use the millimeter wave band, 60 gigahertz spectrum actually, and lower-end devices will try to exploit the sub 6 gigahertz, maybe around 2.3 gigahertz, around 4 gigahertz, and even sub 1 gigahertz is also part of the 5G standard actually. Okay? And they are not freeze the standards in 5G, so I'm not able to give you a correct figure on that. But normally it covers the entire spectrum. There are some 5G standards in lower 1 gigahertz spectrum also, in that lower sub 6 gigahertz. So 2 to 3 gigahertz band also it will be using, and we'll be using the 28 gigahertz millimeter wave band, 28 gigahertz, 60 gigahertz band also for the cellular network and Wi-Fi and all things. It will also cover everything, IoT, vehicle-to-vehicle communication. So very soon we can expect a free standard for various applications in the 5G standard. Okay, so having an outline on the basics of wearable devices and what are all required, what are the protocol stack, what are the layers we have to do, how to get started. That's the next question. I want to develop a wearable application. How can I get started? Sorry. So earlier, how we get started? We used Arduino boards, ESP32, Node MCU. They are compact devices. A wearable thing, if you want, you can go for Arduino Lily. That's a very thin board which you can fix to your cloth. Okay, and ESP32 is a nice thing for is a wearable watch kind of thing. It's only for prototyping, but if you make a product with ESP32 and sell, no one will buy it. Okay? So the end product should be with integrated circuits. You have to go with system on chip solution and make a complete product and give it. But for prototyping, we as a accommodation want to do prototyping of some application. How we can do? We can see this kind of boards. ESP32 is a good thing if you are planning to do something like a wearable watch. So you can buy ESP32. On top of that, you can fix a serial LCD. So it comes as a watch actually. You can find ESP32 with a serial LCD. You can find a watch kind of thing. So you can attach sensors to it and you'll be able to monitor and display the values in that small thing. That is a feasibility. And there are some boards from STM32. You see, it's very thin. Almost it's like wearable. You can have in your packet or you can fix it to your body on the cloth. It is very thin. You can do that. Okay. There are more options. You have to explore the slimmest boards, which consumes. You have to see the power option, lowest power, easier interface. Okay, and weightless, very small boards with more features. You have to explore. This is one popular thing for wearable device implementation, and this is not widely available in the market, but this will be more exactly a wearable board. It is programmable. You could see the USB micro USB port here, and so you can implement some wearable applications with this Limber board. It's a true wearable device, I could say, because it's very slim and you can program for different applications. Okay. So this is about the hardware actually. So what are the software tools? Suppose I don't want to buy any hardware, but I want to do a virtual implementation of a wearable device. You can do that with ARM virtual hardware. Okay, so it's a new thing they are introducing. Normally, if you want to prototype, you need the board. Some board you should use to prototype. With this only, you'll be able to verify your programs and all that. But now, this ARM virtual hardware is providing a feature, a software, a virtual environment. Okay, recently, this 22 only they are introducing that. So you can register and you can get access to this ARM virtual hardware, and you'll be able to implement your ideas in this virtual hardware environment. Okay, without any physical board, you'll be able to implement the complete system on chip solution for a wearable device. Actually. we'll be able to prototype it with this virtual hardware. So recently, ARM has launched this ARM virtual hardware for wearable devices. We can make use of this to practice or implement your ideas for any wearable device applications. Okay. Right. So sorry, I couldn't go for 2 hours. With this, I end. I have another class. So now I'm open for questions. If you have any doubt, you can ask.
The participants are requested to interact with Dr. Sukhdev.
So I have given a general overview. Okay, so what things are there, what required, and what are the areas we should be aware to implement a wearable device application. Okay.
Anybody, please, participants are requested to.
Hello.
Yeah. Yes, sir. Yeah.
Go on.
Yes, sir. Yeah, you are audible. Yeah, I could hear you.
Sir, could you suggest some algorithms related to the security applications, new algorithms in data transmission?
New algorithms, when you say, so, okay, you want to learn about the latest security algorithms, yes, right?
So wearable devices, we are using the
lightweight protocol, yes, of course. Yes, sir.
Any specific algorithms for the
so usually, sir, that standard we want in network we use the standard RSA was older. The advanced one next to RSA. Could you recall that? No. In normally network security, could you list out the protocols we use? The best security protocol.
That is a DES algorithm, AES algorithm.
Ah, yes, that one. That is what being used actually. ASC algorithm. That one. That is being used actually. So because when you implement for an application, always will go with the standard one. What is being approved actually. So if you are trying to make modification, that we can try. But in a product, we have to go with the standard, what is approved as a standard. That only we should use actually. So if you are doing a research, you can try changes in that. But as a product, if you give, it should come with the standard approved protocols. And then only all the device will be able to get data from that. Okay.
Okay. So it is the we can use a standard protocol only.
Yeah, standard protocols.
But in a wearable device, whether it's possible to reduce the power consumption or area for the particular device.
That is about the chip device, sir. That's what I'm saying. So that's what these people are doing actually. VLSI. See, there are different domains in this. If you are a VLSI person, then you can think on working on system on chip design. So you can,
that's why I'm asking that.
Yeah. So one thing is, as an application engineer, say I am an embedded system engineer. So what I will do, I will make a search of which is the best low power board for wearable device. Something I have shown like this. So it is my job to explore all the various microcontrollers available as of now, and I compare the parameters and choose which will consume less power and have best features for that. So as a application engineer, I will not go into the chip design. What is available in the market, I will compare, explore, then I will choose the best for my application. VLSI engineer, they will see the application requirement and they will go on designing the chip. So what are the features required for this wearable device in the future? They will foresee and they will try to add all those features in that particular system on chip. I see they will make it and then sell it. Right? So we will say people should, but anyhow, your final product, wearable device product should be a system on chip product. So only they can make a final product actually. For prototyping, we can try it. Say I have idea, I'm an electronics engineer, but I don't want to spend cost on fabricating that system on chip IC for my application. I just want to do a proof of concept. This is my idea. So I want to just verify the proof of concept. Then this kind of boards will be good to start with. Okay. And even this virtual, if you want to go for that, I have shown different layers of software, right? That higher layer software stack. So the entire full stack for wearable device can be verified with this ARM virtual hardware. You can browse in Google you will see this ARM virtual hardware for wearable device. We can go for a full-fledged simulation of our ideas.
Okay. Thank you, sir. Thank you, sir.
Thank you, sir.
Anybody else, please?
So mostly for academic people and students, they can use the slimmest boards available, and we can do a proof of concept. That would be okay. That would be okay. Then if the concept is good, you can approach company. They will try to make ASIC. You can do that.
Hello.
Yes, sir.
Sir, I have one question regarding for the ultra-wideband antenna. Sir, for designing of ultra-wideband antenna for wearable devices,
Okay.
which algorithm is preferably used for the research purpose?
Actually, as of now, the powerful algorithm is AI, sir. You know, algorithm is meant for decision making, right?
Okay.
You are asking me the algorithm decision making, or how to find that width and all that dimension of the antenna, finding the dimension of the antenna, or something else.
Means.
So you want to design an antenna. For the first thing, what you need is the specific frequency, right? What frequency band? Okay.
Yeah.
Then what will be your next task?
Next question is that which algorithm is most probably used for in a variable application?
Why algorithm is required? Antenna is not related to the algorithm, right? You are going to fabricate the antenna, so you have to design the structure. It is a structure, right?
Yeah.
The antenna is a structure, so you have to think on how what type of antenna you can use. Maybe a flexible antenna. That materials you can explore the materials. So a polyester kind of plastic kind of materials, or a dielectric material, and you have to think on how compact you can make. That's very important thing. How compact you can make your antenna. Mostly for wearable device, they will use that microstrip antenna. This is a microstrip structure, right? A strip kind of thing will be acting as antenna. So mostly this will be the preferred type actually. So the shape, size, and the structure, it's up to you. This is where you can do research.
Okay.
So you can try to, for example, some people could have done. He has made a 0.5 centimeter square antenna. Okay, it's giving out a gain of say much gain will not get 0.1 dB gain he has got. So then you can try in the same area. Is there any possibility of getting higher gain? You can explore. That's one thing. And the other thing is you can try to reduce the size lower than that. And return loss, VSWR, these parameters you can try to reduce when compared to the previous designs they have made. Mostly, it is system on chip, right? So antenna will also be integrated along with the chip. Integrated antennas they may use, or worst case, this will be the microstrip. So in that smartwatch means some kind of tracks they will put, and that will be acting as an antenna. Mostly it will be the microstrip kind of antennas they will be using. So in the same PCB, the H-shaped portion as an antenna actually. So you can think on the size, the shape, it's up to you, because different shapes could give different characteristics, materials. So this is where the area you can explore, sir. So as an antenna designer, you have to bother about the algorithms.
Okay.
The structures, you can explore the structures. Maybe if you are working on fractal structures, you can use AI algorithms. So some AI algorithms you can use to find out which structure would be good to meet these parameters. So that you have to create network, train, and you have to do that yourself. So network is created already there. Some network you can choose, but you have to train it, and then you give input. It will give some valid inputs to you. With that, you will be able to design antennas.
Okay, thank you so much, sir.
Okay, welcome, sir. Only for standard antennas only, we can have some algorithms. Say, for example, a rectangular patch antenna, if you want to design, algorithm will be there. You can give frequency, what gain you want, what material you want to use. It will give the length, width, and all that. That is for standard rectangular or circular shapes, it is available. But if you are making your own customized antenna, we have to explore that.
Okay, thank you so much, sir.
Okay.
Because your information is valuable to me in my research work. Thank you so much.
Thank you.
Anybody else, please, wants to talk with Dr. Sukhdev, please? Fine.
Okay, sir.
Thank you so much for your presentation, sir. It's most valuable and most informative.
Thank you, sir.
And I'm very happy with your time and presentation
Thank you, sir.
in spite of your schedule.
Um,
Yeah, please. This is Dr.
Yeah.
Srinivaslu, head of the Department of EC. Yeah,
Okay.
I'm sorry I could not join meeting morning because I had a
No,
meeting.
no problem, sir. No problem. Actually, I was informed 2 days back, so I couldn't.
Yes, sir. It's
any
my
demos.
mistake.
Yeah,
It's
I
my
could
mistake.
have,
You should excuse me.
No, not that. I could have come out with some demos, so it
Yes.
could have been more.
Yeah. In
helpful
spite,
to
you spend time with us.
Okay.
It's
Thank you,
really
sir. Thank you. Thank you.
quite
So much.
happy. Yeah.
Thank you all. I will take it.
Yeah, sir. Yes, sir. Sir,
Yes, sir. Anything?
now I request the participants to. Yes, sir. Thank you. Thank you so much.
Okay.
I request the participants to give a feedback regarding this FDP, because we have actually planned for 5 days, but unfortunately, we don't find a resource person related to this particular domain having expertise, and this will be the last session. We don't have any sessions tomorrow. Am I audible, please? Hello.
Yes, sir.
I request some of you are please respond how FDP went on, and any criticism or anything that we have to correct. Always constructive criticism should be accepted. Unmute yourself and please say something. Anybody? What are the